On the bright side, pun very much intended, the incredibly rapid development of this technology offers much hope for the amelioration and even the elimination of the color rendering problems we've discussed here. Moreover, in keeping with the Academy tradition, it's a mission of the Council to be proactive in facilitating the development of new technology, as we can bring to bear the insight of the Council's formidable brains trust to both identify problems and possibly point the way to solutions. In the minds of many is the notion that discontinuous sources could be corrected with gel filters. This is a somewhat difficult remedy to apply, in that such filters were themselves designed to modify continuous sources. It must be stressed that filters do not change a light from one color to another. They can only subtract, by absorption, some portion of the light you already have. Apply a cyan filter to a red light, and you will not get a cyan light, but no light at all. In our Council study, we've conjectured that there just may be, and we stress may be, some potential in the notion of fighting fire with fire, in that the problems posed by a discontinuous source may be addressed by the deft application of a discontinuous filter. Thus, we're exploring the effect of applying a discrete amount of rare earth materials, for example, the neodymium we discussed earlier, along with other elements, to a filter that may be applied either at the light or even at the camera, or indeed in the camera. A filter with a particular transmission spectra, when superimposed over the diverse sources we're now encountering, such as tungsten, fluorescent, and solid state, just may bring them all into sufficient accord as to make the differences acceptable. However, such a draconian measure, even if successful, consumes so much light as to defeat any potential economy. One might as well have stayed with the studio tungsten. At this stage, it's clear that we have a plethora of sources that may be present on a stage at a given moment, and that while any of these disparate sources may be individually amenable to color correction, correcting such divergences in multiple directions at once is impractical. Further, the situation becomes exponentially more complicated if one includes the condition where more than one type of camera is employed. Just look at the disparities evident in these sensitivity curves, and then contemplate what happens when these are cascaded with all the variety of lighting sources we've been discussing. We suspect that nothing could then resolve the resulting chromatic chaos. We'll report in the future as we proceed with this line of inquiry. But with $75 million in Department of Energy research grants plus a huge investment from the private sector, it should be possible to address our color rendering concerns expeditiously, provided those concerns are clearly defined and enunciated, and then provided that the solid-state lighting industry regards the interests of the motion picture community and the rest of the color reproduction community as warranting the effort and investment. What's needed is that the manufacturers, presently intent on rushing product to our market, pay attention to the concerns we're raising, lest the shortcomings of these early products poison the well and cause our industry to reject a promising new technology. So with this background, let's review the devices used in Darren's film experiment. First, our rainbow test with tungsten, followed by lamp number 2, a white LED, and then lamp number 3, another white LED, and finally number 4, a multi-band LED. And with our split Macbeth analysis, tungsten with number 2, a white LED, and tungsten with number 3, another white LED, and finally with number 4, the multi-band LED. And here they are all on the screen together. And just for comparison, let's look at HMI and xenon, two lights with which we've been working in this industry for some time and with which we're quite familiar. In conclusion, then, we've shown that we have the advent of an extremely attractive lighting technology, one that offers great economy, flexibility, and versatility, but one that is also fraught with peril, in that absent a proper understanding of the color rendering issues attendant on this new lighting instrument, serious unintended and exceedingly expensive consequences can ensue from their use. We further demonstrated that existing metrics for quantifying light source color rendering are inadequate when applied to motion picture imaging devices, be they film or digital. And these will need to be replaced with more meaningful and useful metrics, if indeed that's possible. Thank you.